In this lecture, we'll discuss regarding isomerism. So, what is isomerism? Isomerism is the phenomenon in which organic compounds have the same molecular formula but different arrangement of atoms around the carbon skeleton. Now, due to this different arrangement, the compounds exhibit different properties. Isomerism subclassified as structural isomerism and stereoisomerism. So basically in this lecture we'll discuss regarding structural isomerism, which again subclassified as chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism and ring chain isomerism. In stereoisomerism, it is again subclassified as geometrical isomerism and optical isomerism. Geometrical isomerism seen in the compound which are having double bond. So in these isomers, they differs in the spatial arrangement. So the atoms change in the spatial arrangement. What is optical isomerism? In which the isomer differ in the arrangement of atoms in 3D space and they create mirror image of each other. First, we'll discuss regarding chain isomerism. So for an example, we take pentane, which is having the molecular formula C5H12. Okay, so the first one is the normal pentane, simple chain like CH3, CH2, 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 CH3. If the one CH3 group is attached to the second carbon, the molecular formula will remain same as C5H12. However, because of this attachment of CH3 on the second carbon, the compound is different, which is known as 2-butane or isopentane. If one more CH3 is group attached to the second carbon, then it is termed as neopentane. So, these three compounds are different but having the same molecular formula, which is termed as chain isomerism. Coming to positional isomerism. So over here, the position of the main functional group, in this case OH, it differs the position, okay, in the different carbon compounds. For an example in this, the first carbon is attached to OH, which is termed as 1-pentanol. If the OH group is attached to the second carbon, then again you will get a different compound, 2-pentanol. And if the OH is attached to the third carbon, then it is 3-pentanol. So the position of the OH group is differ in all these three compounds. Now what is functional isomerism? You can see over here, functional isomerism, the name itself suggests there are different functional group. Same molecular formula C4H8O, but in this you will find C double bond O, ketone. In this case, the carbon is attached to OH functional group. And in this case, 2 carbon attached to oxygen, which is termed as ether. So you will get entirely different properties because different functional group. And these compounds are under functional isomerism. Coming to metamerism, so it is limited to molecule having divalent atom. What are divalent atom? Like oxygen, sulfur, alkyl group. So in this case, the molecular formula again we are taking C4H10O, right? But if the oxygen is between two carbon at this position, and in this case the oxygen is between the second and the third carbon. So these because of this change in the position of the oxygen, you will get entirely different ethers. Now coming to tautomerism. So what is tautomerism? In this, there is interconversion of two different groups. Okay. So interconversion of two different isomers. Now this is spontaneous interconversion. So for an example over here, the keto form. Keto form means the compound having ketone, C double bond O. If it is interconverted into enol form, enol means en means having double bond and ol means OH. So over here, two compounds exist in equilibrium. So over here there is prerequisite, like the compound should have C double bond O group or C double bond N or N double bond O. So but the most usual is ketoenol tautomerism. There are other kinds of tautomerism like nitro-SC tautomerism or amine-imine tautomerism. In this case, again, both compound will not have the same stability. Okay, so in this case, you can see the keto form is more stable as compared to the enol form. And the enols can be formed by acid or base catalysis from the ketone and are extensively used in making the carbon-carbon single bonds in organic synthesis. Coming to ring chain isomerism. In this case, you can see over here the molecular formula is C3H6. That means it is propene, CH2 double bond CH, CH3. Now, if you change the arrangement of atoms such that it becomes a cyclic compound, which is cyclopropane. So, this is known as ring chain isomerism. This is ring structure and this is chain. So, propane is an alkene while cyclopropane is an alkane. So, there are two different kinds of compounds. So, this is regarding the ring chain isomerism. I hope you are clear with this structural isomerism. Next, we will discuss regarding the stereoisomerism. Thank you.